This is the fifth and final lesson in the fractions unit. We're solving word problems involving fractions today. What's really important to do when you're looking at a word problem is to look for some keywords that will help you figure out which operation to do. Like, is it an adding problem, subtracting, multiplying, dividing? So we're going to write down together some keywords that might help us figure out which operation we're doing in different word problems. So adding. Common ones would be like altogether, total. Now, just because you see these words in a problem, some, doesn't mean you're definitely doing that operation. It's just kind of like a clue. Now, if I was doing this with a class, this lesson, I would probably get students to brainstorm, but because it's just me teaching here, I'll just tell you what these keywords are. Subtraction, take away. Any kind of like reduction, reduce, decrease, lower, decline, anything that means like to go down, essentially. And another one for subtraction, if you're comparing two values and saying like, how much more is this compared to that? So how much more then? Like if I have $20 and my student has $8, I have $12 more than them. So I would subtract the two numbers to figure out how much more. That's a common one. Okay, multiplication, really important with fractions, is the word of, especially when it follows. I mean, of is a pretty common word, but when it comes right after a fraction, that's usually an indication you want to multiply. I'll write that better, when it follows a fraction. Another one is simply times. So like when you want 3 times as much, then you would usually multiply. Divide is not really about the keywords, but more of like the idea of the problem. So whenever you want to split something into equal parts or share something. Okay, there we go. Okay, so what we're going to do is look at each word problem, look for those keywords, and then solve the problem. Okay, let's do it. First example, I have a 6.5 foot long piece of wood that needs to be divided into 4 equal length pieces. How long will each piece be? So this is a problem where I'm splitting into equal parts. So the operation I'm doing here is division. Okay. So I'm going to show my work. So I have 6.5 that needs to be split into 4 equal parts. So I'm going to divide 6.5 by 4. I use feet here, imperial units that are used typically in the United States, because in those type of units we often have fractions. Okay, so first thing I need to do is change this to an improper fraction. So 6.5 is the same as, so 6 times 2, add 1, you get 13 over 2. And now I'm going to keep change flip because I'm dividing. So it's going to be keep the first fraction, change the sign, flip the second fraction. And I'm going to look for any ways to reduce it. Looks like I can't reduce, so I'm just going to simply answer it. So it's 13 over 8. Now, in a regular problem that wasn't a word problem, I would just leave it as 13 over 8, but because the original word problem had a mixed number, and you would see like measurements like this written as mixed fractions, we do want to convert it. So to convert it, we want to figure out how many 8s go into 13. So there's 1 hole in there, and then 5 left over. So that would be the final answer, and we would always want to write a little sentence for our final answer. So each piece, and to write your sentence, you can just start with the question and just start it. So it's like, how long will each piece be? Each piece will be 1 5/8 feet long. Okay, good. So steps are, when you're doing a word problem, figure out what operation you're doing based on the keywords. Okay, then answer the question and then write a little sentence Okay. A cake recipe calls for sugar to be added in 2 different times. Oftentimes, when we're baking, we're using fractions a lot, especially if the units are imperial. First, we have 2 1/3 cups are added to the cake batter, and then we need another 1 3/4 cups added to the icing. How much sugar are you going to need all together? So here's our keyword, all together. So we are adding here. Okay, so here's my work. 2 1/3 plus 1 3/4. We need to make them improper fractions. So we are changing them to 7/3 plus 7/4. We need to make a common denominator because we're adding. Denominator. That's a good review of all the skills we've learned in this unit. So we're going to make them both out of 12. Right now they're 3 and 4. So to make 12, I'm going to multiply this by 4, and I'm going to multiply this one by 3. So this will become 28/12 plus 21/12. Now that they have a common denominator, I can go ahead and add the numerators together. So 21 plus 28 is 49/12. Oops. And we are going to change this back into a mixed number because it is a word problem and the original fractions were given as mixed numbers. So it makes more sense to write it, our final answer, in that way. So 12 goes into 49 4 times, and then there's 1 left over. So we write this as 4 1/12. So our final answer would be, and just start with the question, how much sugar do you need altogether? We would need just over 4 cups, 4 1/12 of cups of sugar for this recipe. Okay, great. Next and last question. Let's look for our keywords. Sarah works at Starbucks and noticed that about 2/3 of the customers order a baked good with their drink. If Sarah works for 8 hours on Friday and serves 150 customers, how many bought baked goods? So this is a problem that's a little bit trickier than the other two because there's a number we don't need at all. This number is not, we're talking about the number of customers here. So this 8 hours is unnecessary. We don't need to use it. The key word here is of, especially when it follows a fraction. That's when it's usually going to need multiply. So if we want to know how many ordered baked goods, we're going to do multiplication here. So we're going to do 2/3 of 150, which is the same as 2/3 times 150. Now we are going to reduce before we multiply here. You notice that 3 and 150 both can be divided by 3. So I get 2/1 times 50/1, which is 100/1, which is just 100. So here's my final sentence. How many bought baked goods? About 100 customers bought baked goods, assuming this pattern continued. Baked goods. Okay, there we go. And that is the end of the lesson.